Vaishnavi. We are students of class 7C. We are here on Mathematics Day to represent our model on properties of parallel lines. Properties of parallel lines. Corresponding angles. When two parallel lines are cut by a transversal, the pair of the congruent angles on the same side of the transversal are called corresponding angles. This is a representation of corresponding angles. Co-interior angles. Two angles that lie between parallel lines on the same side of the transversal are called co-interior angles. This is a representation of co-interior angles. Alternate exterior angles. Two angles that lie outside parallel lines and opposite sides of the transversal is called alternate exterior angles. The color green and yellow represents alternate exterior angles. Alternate interior angles. Two angles that lie between parallel lines on opposite sides of transversal but not a linear pair is called alternate interior angles. The color green and blue represents alternate interior angles. Thank you.
Good morning. We, the class of 8B, are presenting Polygon interior angle finder. This is used in schools and many places. And
Abhishek, I have a question. So you told that this project is used in school. So how can you find out the interior angle for square?
for example, let's take square. First we have to take the thread and we have to make the square. As you know, square has four sides, of course, and you have to keep the protractors on the line. As you can see, the result is 90 degree, 90 degree over here, 90 degree over here, and 90 degree. And when we add all the four, we get 360. Okay? And for example, let's take triangle. Even when you add all these, you get 360. And it proves that when you add all the when you take any polygon and the interior angle is 360. And this can be used in children's by like 3D and virtual, and children's will get more interesting in the explanation and the lesson. Thank you.
Good morning everyone. Today we are going to explain on pie chart. You might be thinking, what is pie chart? A pie chart is a circular graphic which is divided into slices. The arc length of each slices is proportional to the quantity it represents. The formula for to calculate a pie chart is to divide by 360 and multiply it by 100. Now my friends here will give some examples and advantages of pie chart.
Pie chart represents data for many things. We can represent data like the budget, the growth of the country propagation, then we can also check it for the growth of the crops every year, etc. There are many advantages for using the pie chart. Pie chart is, on the pie chart, when we represent data, it is very simple and can be understood by everyone. Now my friend Abbas will explain the sum based on pie chart.
We are doing the pie chart problem. So see, we have taken a countries and percentage. Countries example, we have taken countries as India, China, Russia, USA, others, and total. You might be thinking why we took Russia and USA as A. Russia because we need to find as Russia and USA. Others means in the sense of these countries. Percentage for India we have taken as 15, for China 20, Russia's A and USA A, others is 25, and if we add total, total means 1% is equal to 100. So total percentage 15 plus 20 plus A plus 25 is equal to 60. 100. So we have to do total is 100. 100 is equal to, when we add this 60. Now numericals without the variables. 60. When here the variables are means we add it as 2A. 100 minus 60 is equal to 2A. A is equal to A is equal to 40 by 2 because here 40 by is equal to 28. 60 minus 100 is 40. A is equal to 40 by 2. When we simplify, we will get answer as 20. See, now we have to measure of centralized angle. As previous I have told you that the formula for calculate pie chart is to divide by 360 and multiply it by 100. So we have taken as 50 by 100 into 360 is 54 degree. 20 by 100 is into 360 is equal to 72. 20 by 100 into 360 is 72. 25 by 360 into 100 is 90 degree. Thank you.
Hello everyone, so we are from 11th grade of St. Joseph School, and today we are demonstrating a simple application of calculus. So let us learn something about calculus. So I would like to start with a small story. So there's one girl who drops an object from a height of 1 meter. She practically thinks that it shouldn't fall on the ground. Mathematically speaking, the ball will first travel half the distance, then 1/4 the distance, then 1/8 the distance, and so on and so forth till infinity. And the time it takes would also be up till infinity. And then to calculate the instantaneous speed of the ball at any given time, assuming that everything at that moment would cease to be, it would be 0 because the distance travelled by the ball and the displacement and the time taken by the ball would also be 0. So in such complicated calculations is where calculus comes into play. So let us now look into a few applications of calculus.
Okay, so understanding what calculus is basically breaking down big things into small things and building up small things into bigger ones, right? So the first application is in civil engineering. So if you look at a building, a building has to support various different amounts of weights, be it the weight of the materials that is used in it, or be it the weight of the furniture that we put in it, or the people and the things that they carry and so on. So these are all very small things which contribute to one large thing, right? So we use calculus to understand exactly the total amount of weight a building's foundation would have to withstand, and using that we calculate the amount of material which has to be used, or the area which it has to occupy, or the materials which have to be used, and so on. Next we have calculus in aeronautics, which is basically used when we launch rockets into outer space. So be it for orbiting the Earth or sending probes to the moon or so on. So we use calculus to take into account the air resistance of the different layers of the atmosphere, as well as the gravitational influence that any of the other celestial bodies like our sun and our moon might have on the probe. And based on that, we calculate a trajectory that the rocket might have to follow, along with the velocity and so on. And then you have calculus in medicine. So calculus is used especially when it comes to pathology, right, and as well as in places studying cancer, where we have to understand the growth rate of a particular disease, or the growth rate or the diminishing rate, that is the the shrinkage of a cancer tumor and so on. So we use calculus to understand exactly the stage at which a particular cancer cell is, or the stage at which a particular disease is. And we also use it in cardiology, where cardiologists use calculus to understand the exact flow of blood through any particular blood vessel, so that when we're doing an aorta transplant, for example, we use calculus to understand the flow of blood in that particular blood vessel, and we make the transplant in such a way that the particular blood flow is proper in that area. And then you have calculus and business, which is used in things such as credit card payments, where we use calculus, banks rather use calculus to understand the fluctuating interest rates and the fluctuating balance and so on, and based on that they devise the different payment structures which is used in the different credit card plans. And also we have the stock market, where calculus is used for making different options as well as the hedging of said options. And finally you have calculus in music, which is used in harmonics as well as acoustics. Harmonics is used in understanding the oscillations of a particular instrument as well as the air resistance and so on, so that we can soundproof a particular place, or we can enhance the sound in a particular place. And acoustics is basically used to understand forced vibrations and forced oscillations as well as resonance, and we use that to basically improve a listener's experience in, let's say, an opera house or a movie theatre or a cinema hall and so on. And that brings us to the end of our presentation. Thank you.
So now that we have looked into a few applications of calculus in daily lives, we would like to demonstrate a small application that we could do right now. So here, let us assume that we have to find out the volume of this cone, right? So we have to assume, we have to find out the volume of this cone, but we don't know how to find it. So how this cone is made is basically by stacking infinite number of discs one upon the other, like how we have shown here. So now that assuming we know how to calculate the volume of each cylinder, we will have to find out the volume of the cone. So here, as you can see over here, we have taken small h and small r to be constant height and the radius. And as the height increases, we see that there is an inverse proportion over here. As the height increases, there is a decrease. And so to get a direct proportion, what we do is just invert the cone, and here we can calculate with the help of the direct proportion a simpler equation which will help us to calculate in a much simpler manner. So here we know that the area of the base would be pi RH, and when we are substituting the values over here, and when we are summation, there's a summation, that means we are adding area of everything times the height. Area is one dimension and then the height the other dimension. When we are multiplying it and we are doing the summation of every single disc that we have stacked one upon the other to get a cone, we finally get the volume of the cone by integrating, and then again by after differentiation and integration we follow a few steps and rules, and finally we land up with the equation for the volume of the cone.
Good morning to everyone present here. I am Vivian M of class 8A, and this is my partner Abdul Rahman, who is of the same class, and we are here to present you the project of Pythagoras theorem. And this project is a simple working model which shows how to calculate the three sides of the Pythagoras theorem right angle triangle, and the hypotenuse is the longest side among the other three sides of the triangle, and which is located opposite to the 90 degree.
The square of the hypotenuse is equal to the sum of the square of other two sides. The sides of the triangles have been named perpendicular, base, and Pythagoras theorem states that the hypotenuse of the square is equal to the sum of the square of other two sides. The sides of the triangle have been named hypotenuse, perpendicular, and base, and Pythagoras theorem is used to find out the sides of the right angle triangle, where if we know the two sides of the right angle triangle, we can find the third side. Thank you.
We are students of class 8. We are representing the topic graphs. In that we are mainly focusing on line graphs. There are various types of graphs: line graph, double bar graph, bar graph, pie chart, and etc. Line graphs are mainly used to depict the economic factor over short or long period of time. This is an example of line graphs. The man starts to travel at 8 a.m., 5 a.m. And travels 20 kilometers and the rest at 6 a.m. The horizontal line on the graph represents that the thing or an object is on rest, and he starts again to travel from 8 a.m. and stops at 9 a.m. He again travels 20 kilometers. After that he is at rest. Till 12 a.m. he is at rest. After that he starts to travel at 1 a.m. and travels 40 kilometers and again goes to rest. Thank you.
Good afternoon. Our project is on the practical application of 3D geometry.
3D geometry has many applications, but its major application is used in technology. For example, in game creation. In game creation, we see many domes, bridges, etc. It is done by the help of 3D geometry. It is also used in movie creation, like this.
So the next topic we have is architecture. So architecture in 3D geometry is one of the most crucial and important steps while making a building. It is also used in making statistical decisions while constructing a bridge. And the type of geometry used in architecture is Euclid geometry, which is based on axioms and theorems.
Planetary motion. In math, we can represent any celestial formula. any celestial phenomena occurring in space using 3D geometry. It explains many physical characteristics. Then the Cartesian form of an elliptical orbit helps in explaining the phenomenon of planetary motion occurring in space, which also helps in simplifying and studying the other various events occurring in space.
Okay, next we're going to see the application of 3D geometry in MRI scans. So these scans have various geometrical patterns and designs which help us detect what kind of a problem exactly that person has. So these scan images are from radiographic sources like MRI scans and CT scans. They help trace the neurons and also they help in the detection of the tissue samples. So that's about MRI scanning.
Next is medicine. In medicine we have bioprinting. Bioprinting can produce living organs, tissues, blood vessels, etc. which is used in medical procedures, testing, surgeries. Here we have heart valve. Heart valve acts as a door in the heart for the blood flow and preventing backflow when the heart gets blocked. We use 3D geometry scanning to detect the blockage and to create a new one according to the patient's requirement.
Air navigation. An extensive use of 3D geometry is in air navigation. As depicted in this picture, ILS or Instrument Landing System as well as the system behind autopilot is designed on the principle of 3D geometry. And target engagement. With the current scenario of the modern world, a nuclear threat is impending. 3D geometry is unfortunately but extensively used in designing standard engagement systems for missiles. Thank you.
Hello everyone, my name is Tamanna and I am here to introduce parabola. In mathematics, parabola is a U-shaped curve which is symmetrical to the y-axis. So my colleague Angelo will continue further.
So, how is a parabola formed in a cone? So, the way a parabola is formed in a cone is that any line which is slant or parallel to the sides of the cone will be a parabola. Example, as here, this part is parallel to the sides of the cone, hence making a parabola. Now, let us get into the demonstration. So, what we have here is a catapult, and I'm going to show you a parabolic motion with the example of this catapult. As you can see, that was a parabolic motion. This would apply to all projectiles. So let's discuss why the catapult took a parabolic motion. So let's assume there is a projectile which is thrown with v velocity. So the projectile is moving in the x and y directions. The reason it moves forward is because there is no gravity acting on the x direction. So it moves forward. But in the y direction, gravity takes hold of the projectile. So as gravity is taking hold of the projectile, from here, gravity keeps on acting on this projectile from this point till the end until the velocity becomes 0 in the y-axis. That's why the projectile stops. Now, let's look at some interesting properties of parabola. So the main use of parabola is through this property. So the property is whenever there is a ray which is parallel to the focus of the parabola, that's when the ray, any ray, will pass through the midpoint or the focus of the parabola. You will see in these examples how that is very important. So, The first example, the parabolic solar cooker. So let us assume the solar cooker is at the focus of the parabola. So as we have discussed, any ray that comes parallel to the focus will indeed pass through the focus. So if we keep a solar cooker at the focus, all the rays of the sun will directly interact at the solar cooker, which concentrates light, which makes the solar cooker more efficient. Let's look at the second example, radars. So, by the same principle, there are many radio signals which keep coming on this dish, and all of them come parallel to the focus. So, all these radio signals have different kinds of information, and scientists need to collect them through one medium, and that medium becomes the point here, which is the focus. So all the radio waves converge at this point, and all the information is thus collected efficiently. Let's look at another example. The Olympic torch. It's the same principle as the solar cooker, that all the rays converge at a single point and it becomes easier to light the flame. Now, the infinity mirror. This is something interesting. So what happens here is that you have two parabolic mirrors which are parallel from one focus to the other. So when light comes from one focus, it bounces to the other focus and keeps on reflecting, creating an infinity mirror. Now I will ask Tamanna to conclude.
So in conclusion, parabolic graph is a smooth U-shaped curve that depends on the sign of the coefficient. Carries on whether it is upwards or downwards. The better and the intercepted, the 2 points that make it very easy to graph is parabola.
Thank you. Greetings everyone, my name is Sushmit and my name is Simon, and the topic of our group for today is trigonometry, the geometry of reality. Through our presentation we shall be going over these topics. First we will look at what trigonometry basically is, then we shall look at the basics of the art, then how we use it in real life, including a few advanced applications, and where we can find it. What is trigonometry? If we take this word, its origins go back to the language of Greek. We can break it down into two separate words, trigonon and metry. Trigonon is triangle, it translates to triangle, and metron or metry means to measure. So basically trigonometry means the measures of a triangle. What can we measure in a triangle? The angles and sides. The first line, trigonometry is one of the most important branches in mathematics that finds huge application in diverse fields. So from this we know how important trigonometry is. Second point says the branch called trigonometry basically deals with the study of the relationship between the sides and angles of the right angle triangle. Also trigonometry is applicable only to right angle triangles. Now we shall look into what a right angle triangle is and how we use trigonometry on this triangle. So a right angle triangle is a triangle with one angle which is 90 degrees, this one. And the side opposite to the right angle is called the hypotenuse, and it is usually the longest, not usually, it is always the longest side of the triangle. For our study of trigonometry, we have to mark an angle. And we usually mark that angle as theta. It can be this one or this one, but not the right angle. So on the basis of theta, the side which is adjacent, or the side which theta is touching, is called the adjacent side. And the side opposite to theta is called the opposite side. We have a few functions, mathematical functions of trigonometry. which are the 6 of these. What are functions? Functions are basically fundamental actions of maths, operations. So now these functions are ratios, which are divisions. If we look into our sine function, which is sine of theta, that is the ratio of the opposite side to the hypotenuse side. And the reciprocal of the sine function is the cosecant function. Cosecant function, or for short cosec theta, which is the hypotenuse by opposite. What does the reciprocal mean? It means the denominator becomes the numerator and the numerator becomes the denominator basically. So as we can see here, opposite by hypotenuse and hypotenuse by opposite. Similarly, we have the cos function or cosine function, which is the base by hypotenuse, base as an adjacent. And the reciprocal of the cos function, secant function or sec theta, hypotenuse by base, again reciprocals. Tan theta or tangent of theta, opposite by base or opposite by adjacent. And cot theta, the reciprocal of tan, base by opposite. So we use these ratios to work with trigonometry in maths.
Now we are going. So let's imagine there is a person standing here, and the distance between him and the foot of the tower is 25 meters, and the angle is 75 degrees. So we have to find the height of the tower. So let's keep it as x. So in the figure, if we name it as ABC, angle C is 75 degrees and BC is 25 meters. So we have to find AB. So we have to use tan function, tan 75. So tan 75 will give us opposite by adjacent, that is x by 25 meters. So tan 75 can be broken as tan 30 plus 45 degrees. So using this formula, tan x plus y is equal to tan x plus tan y divided by 1 minus tan x into tan y. So applying 30 and 45 as x and y, we get that tan 45 is 2 plus root 3. And we also know that tan 75 is opposite by adjacent. So we got on simplifying that it is 2 plus root 3 and it is x by 25. So solving for x, we get it as 93.3 meters. So the height of the building is 93.3 meters. Now we come to the second situation where the height of the building is known and the angle is known. We have to find the distance between the observer and the foot of the building. So let's name it as y. And the angle of inclination is 15 degrees. So here tan 15 can be broken as tan 45 minus 30 degrees, and tan A minus B can be written as tan A minus tan B divided by 1 plus tan A into tan B. So solving for tan 45 minus 30 degrees, we get it as 2 minus root 3. And we also know that it is opposite by adjacent. So it is opposite by adjacent, so 10 by y. So solving for y, we get it as 37.32 meters.
So we looked into how we use trigonometry to calculate heights and distances. There are many more diverse applications of trigonometry, very advanced, and trigonometry is basically very useful. So we shall look into how it is used in real life. Firstly, it is used in aviation and aerodynamics, basically planes and flight. Trigonometry is used in aviation engineering. It is used to calculate the climb angle, the flight path, distance traveled, and the descent angle that is required to land a plane. Climb angle is the angle with which the plane should basically incline with the ground for it to have a proper flight, takeoff. And descent angle is the same thing but the other way around, the angle with which the plane should incline to land properly. And flight path is the path of the flight, distance traveled is the distance of the flight. Next we shall look into how trigonometry is used in astronomy and criminology. Under astronomy, astronomers use trigonometry to calculate the distances of stars and planets from Earth. Today, scientists use it to construct and launch space shuttles and rockets. An interesting fact is also that humans would have never made it to the moon without trigonometry. In criminology, trigonometry can be used to estimate what might have caused a collision in a car accident, or how an object fell from somewhere, or in which angle a bullet was shot. So these applications are basically dealing with the angles. So in a practical situation, we would break the total distance into a triangle, a right angle triangle, and using that we can find out the angles and distances as we saw. Next, we shall be looking at how trigonometry is used in construction. In construction, we need trigonometry to calculate the following. 1. Measuring fields, lots and areas. 2. Making walls parallel and perpendicular. 4. Roof inclination. And 5. The height of the building, the width length which we saw. And there are many other such things where it becomes necessary to use trigonometry. That is it for our presentation. Thank you very much.